All right, hey guys, Mr. Kyle Myers Mathematics, and this problem is for a particular student, but if you're watching this and you're not that student, you can of course still benefit from it, especially if it's exactly the same question as yours. So we're gonna do this problem in degrees because I don't know what you're allowed to use in class. If just trying to generalize it a little bit here, you could either maybe be able to use a graphing calculator, or maybe be able to use a scientific, or maybe you can't use a calculator at all. And if you can't use a calculator at all, then I'll pray for you, because these are some crazy decimals. But the first decimal actually kind of makes sense because if we're talking about meters, then that first number, if you times it by 2, you actually get gravity, which is 9.8 meters per second squared. So this problem takes place on Earth. It doesn't have to, but they like to do that number a lot to make it more realistic. So let's jump into how you would do this with a graphing calculator. I'm going to bring over Desmos so you guys can see this here. Let's see. Okay, I'm looking over here at my monitor so you guys can see this. Make sure that it's blown up nice and big here, but not too big. Actually, we can go this way with it because it'll just go underneath where I am. There we go. Okay. So the simplest way to do it is to just type it in, right? And sometimes on Desmos, you can't just type it in exactly how you see it. If you're using a type of Desmos, like if you're using the Desmos that you would use for the SAT, then you might not be able to type it in how I'm typing it in. You might have to use X and Y. But there we go, squared. And by the way, if you don't know how to do that squared, it's just shift and then the 6 button. It goes up into the power there. And then you right arrow out of it. Plus 34.3t plus 1. You can kind of start to see it taking shape here. I'm going to pinch this screen so you guys can see. It goes up pretty high. This graph goes up pretty high here. So I can also, let's see if I can pinch it outwards. You got to do it like just right to pinch it outwards. I haven't quite mastered that skill yet. But if you wanted to kind of widen the graph up a little bit, you can always do that in the settings over here. So more options, x-axis. Let's see. No, I want it to be linear. Oh, here we go. Steps. No. Yes, here we go. Y, x-axis. And let's do this. So if I tab over, then it highlights the whole thing. Otherwise, it won't highlight the whole thing. So I shift tab, tab to tab over. Because for whatever reason, when you try to like tap it on Desmos, it doesn't highlight it right away. So in order to widen this out a little bit, I can go maybe from here. But actually, I want to go back just a little bit. There we go. And then let's go. We only need to go out to like 10, it looks like. Okay, yeah, that looks a lot better. There we go. Okay. So now we can see where everything is. So it looks like there's 2 x-intercepts, but notice that one of the x-intercepts is way back here. So there's one of the x-intercepts, 0, 1, which we can see if we plug that in. The other thing over here, there's the x-intercept that's in the negatives, but think about it, time being negative, it's like, okay, well, that's not going to be applicable to us. There's another x-intercept over here. That would be helpful if they asked you when the ball was going to hit the ground, but they're asking for the max height. So here it is. It says when, so remember t is the x, so t is going to be 3.5, and y, or h of t, the height, is going to be 61.025. If you need that as a fraction, then you can actually just come over here and you can type it in, so 61.025, and then hit this button right here, and then it'll change it to a fraction if you needed to write it as a fraction if they asked for it. And that's pretty much it. So we already have the answer, right? If you're using it that way. Now, what if you're not? What if you're only able to use a scientific? Okay, well then you would still plug it into the quadratic formula. So remember, the quadratic formula is x is equal to negative b, and I'll need to do a parentheses if you're using a scientific and you want to type it in all at once. X is equal to negative b, and then it's plus or minus the square root. I'm just going to do plus for right now because I don't know which one we'll actually need. We might actually need the minus, but we'll see. All over 2a, yeah, I think we'll need the minus. So actually, I'm gonna go back into the minus. Negative b plus or minus the square root, sqrt. of, now that only works on Desmos. If you're doing it, there's going to be a square root button on your scientific. B squared minus 4ac all over 2a. Okay, and we can add a slider on there, but basically I just wanted to show you the formula on here. But when you plug it in, you're going to be plugging in those values, right? So B is 34.3, 34.3. Plug that in here as well. If B was negative, we would have to make sure that that's in a negative, in a parentheses, but it's not, so we don't have to worry about it. 34.3. There we go. A is negative 4.9. So I do want to put that in parentheses just to be safe here. Negative 4.9. Now, if you're using a scientific, you might want to just type this in all at once rather than see the formula. But seeing the formula was just for your benefit in case you haven't memorized it yet. I would recommend memorizing it. You use it a lot. I mean, you use it all the way through calculus if you're going to go that far. So let's see. The only thing I haven't plugged in yet is C. C is 1. And there we go. So let's see. That ends up being, oh, you know what? I apologize. We did the quadratic formula, which found the x-intercepts. Wrong formula. Hold on, let's go back. So that was how you find the x-intercepts, but we want the max height. So actually we want to use a different formula. We want to use h is equal to negative b over 2a. So we want to use negative b over 2 times a. There we go. So 3.5. And then separately you would plug in 3.5 to get the max height. So this 3.5 is the when, it's the t value. It's 3.5 seconds. When will the ball reach its maximum height? In 3.5 seconds. Okay, so then we plug that number back in to figure out what the y value is. So negative 4.9. And then, and by the way, if you're looking for a particular solution, you can, fast forward or go back. If you need to see this example done by hand, then you can stick around for the rest. Otherwise, don't worry about it. I'm not trying to become YouTube famous. I just want to do these problems to help you guys out. So that's why I was thinking about doing a 3-tier system, where no matter what kind of calculator you are or are not allowed to use, you can still benefit from this. So 3.5 squared plus 34.3 times 3.5. Now I don't need to put that in parentheses. Even if it was a negative, I wouldn't need to put it in parentheses. But the rule of thumb with calculators is if you're not sure if you need the parentheses or not, it's better to just put it, because you can have too many parentheses and still get the right answer. But if you don't have enough parentheses, the calculator will think you're trying to do something else, and it'll spit out the wrong answer. The calculator doesn't normally ever make mistakes. But, it might think that you want to do something else. So there's that answer there. 61.025, that is the max height. And that is in meters. So 61.025 meters. Okay, so I'm going to move this back over here. And what if you needed to do it by hand? So if you needed to do it by hand, we would still use the same formulas, but you would need to do some of this stuff, off to the side, some of the work off to the side. But we would use the same formula. So it'd be negative b over 2a. Right? So then that would be negative 34.3 over 2 times negative 4.9. And if I times both of these by 10, I can get rid of that decimal. Negative 343 over, I'm going to put the negative in the front, negative 2 times 4.9. Oh, sorry, 49. And the reason why I didn't multiply the bottom numbers is because 343 is actually 7 times 7 times 7. And those negatives cancel out, by the way. So 343 is 7 times 7 times 7. 49 is 7 times 7. So I get 7 halves, which is 3.5. Okie doke. It's probably going to be better to write it as a fraction if you have to do it by hand. So now we're going to go back in. We're going to go negative 4.9. And then I'm going to plug in 7 halves. 7 halves squared plus 34.3 7 halves plus 1. Right? I'm going to blow this up a little bit. Seems like it's a little small. Well, it's not that small, actually. Yeah, it's fine where it is. Yeah, I'll just do it like that, I guess. Okay, so 7 halves squared is going to be 49 fourths. So negative 4.9, 49 fourths, plus, that's going to be 34.3, 7 halves. So I'm doing the E step. Now I'll do the M step in PEMDAS. So I times these out. That's going to be 49 times 49, which the little trick for squaring numbers would go like this. 48 and 50. And then I would take 48 and times it by 50, which would be 240. And then that's going to be 2401. So that's 2401, and then that's over 4. Oh, and that has a decimal place on it, so that's going to be negative 240.1 over 4 plus 34.3 times 7 is actually going to be 240.1. Positive 240.1 over 2 plus 1. Okay, so then I can use a little trick. Those are the same number. So if I times this one by 2 on the top and the bottom, it's negative 240.1 over 4 plus 2 times 240.1 over 4 plus, and then I want this to be out of 4 as well, so 4 over 4. Okay. So if I'm going to do 2 times 240.1 and then subtract it by 240.1, I'm going to get 240.1. So 240.1 over 4 plus 4 over 4, and that's going to be 244.1 over 4. And then if I want to change that into a pure fraction, that's going to be 2441 over 40. And I don't know if I can go any further on that, because 2441, what is that even? Let me see what this comes out to be over here. Yeah. Yeah, 2441 over 40 is what the number would have been. Remember we said the answer was 61.025? That as a fraction would be 2441 over 40. So actually that's done. 2441 is probably just a really large prime number. So that would be it as a fraction. If you did want to write it as a decimal, or if the teacher said they wanted you to round to a certain decimal place, then they want a decimal, then you would do it differently. You would have kept it as 3.5 when you went to go square it. So it'd be 3.5 squared, which actually is a little easier to do than you might think, because 3.5 squared, you can use the same little trick. You would round up to 4, down to 3. 4 times 3 is 12. And then you would add a 0.25, the square of the difference. So you'd add a 0.25, and it's 12.25 is 3.5 squared. And then you could times that by the 4.9, and then the 34 point, and then it would end up being pretty similar, but with decimals. So hopefully that's helpful. If that was awesome and helpful, and you're not the student that this was intended for, then throw me a like and that kind of thing. Or if you are, you can still throw the like on there and subscribe and all that good stuff. But really though, I don't really want not that I don't want it to blow up, but it's this is for you guys, and the flashy stuff, that's not really my focus. Just trying to do the math that helps. So yeah, I'm gonna stop ranting now and shut off this video, but hopefully that was helpful. And you can also check out my website for more helpful things, as well as YouTube, Myers Mathematics, which is going to be down below, where I have a PDF guide called The 5 Math Mistakes Everyone Makes and How to Avoid Them. You can check that out for free, myersmathematics.com. See you in the next video.